All right, in this video here, we're going to talk about combined variations, right? So if you haven't seen my other videos, I did one on direct variation, I did one on inverse variation, and I did another one on joint variation. And this one is kind of combining direct and inverse variation into one, right? So in this case, when we have, if we have three variables, sometimes they all vary directly, in which case you have that joint variation where everything just kind of gets multiplied. But sometimes you have three variables and one of the variables is directly proportional to one, but inversely proportional to another one, right? That kind of thing is possible. So you get something like this, where z is equal to k, and again, that k is that constant of proportionality. So z equals k times x over y, right? So in this case, z is proportional to x, right? Because that k is multiplying the x in the numerator, but it's inversely proportional to y. That's why that y is getting divided. Right? Or we can say that z varies directly as x and inversely as y. Right? Direct variation is multiplication, inverse variation is division. Right? So you can have one variable that varies directly with some other variable, but inversely as another, in which case that constant multiplies the one that's directly varying, but it divides the one that's inversely variation. Okay? So I don't think I used those words appropriately there, but hopefully you understand what I mean. So that is what that formula would look like when you're directly proportional to one and inversely proportional to another variable. All right, I am going to pause this real quick, erase these words up here, and put up another problem, and we will work through that one that involves these combined variations. Alright, so I got this example one up here. This one's got a lot of words to it. So we have a person's level of fatness is measured using the body mass index, or BMI. Right? BMI varies directly as a person's weight in pounds and inversely as the square of a person's height in inches. A person who weighs 140 pounds and is 70 inches tall has BMI of 20. Find the BMI of a person who weighs 165 pounds and is 71 inches tall. Right, so a whole lot of information there. We just have to kind of pick it apart carefully, slowly, make sure we put everything in the right place, and we'll be able to work our way through this and figure it out. All right, so first off, what type of variation do we have? Well, it says that the BMI varies directly as a person's weight in pounds. All right, so I'm actually going to erase some of this stuff up here. We understand that the BMI measures a person's level of fatness, so we can kind of get rid of that wording up there. Let me get rid of all this, and so I can write my formula up there, because I don't think I have enough room down here to solve all this stuff. So the BMI, so let me start with the BMI is, I'm just going to call that capital B for BMI, right? So that varies directly, so it's going to be K times directly as a person's weight, right? So it's going to be K times, I'm going to use W for weight, but it also, so it varies directly as a person's weight, but it varies inversely as the square of a person's height. So inversely means I'm dividing by the square of the person's height. So it's going to be B equals K times W over H squared. All right, so again, when you're doing these types of problems with the variation, you have to read that first part very carefully to make sure you get the correct type of variation. Right? If it's just direct variation, you just multiply the K times the variable. If it's inverse variation, it's K divided by the variable. If you have joint variation, it's K times two variables. In this case, it varies directly with one variable, so it varies directly with the weight, so that weight goes to the top of the fraction that gets multiplied by the K, and it varies inversely with the square of the person's height. Right? So that square of the person's height, the H squared, is going to go in the denominator. Right? And just like I said with those other videos, I would strongly advise you to use letters that represent what those variables mean, right? So B for BMI, W for weight, H for height. That way when you have to start plugging numbers in, it's real easy to figure out where each number goes. All right? So hopefully that all makes sense as far as how we decided where to put all this stuff, right? Varying directly means the K multiplies the W. Varying inversely means that variable gets divided. It goes down into the denominator of the fraction. All right? So we got our basic formula set up. We have all that stuff. So now that we've got all that, I'm going to erase that part of the problem because we don't really need that information anymore, right? That information just served to tell us how to set up our formula, what type of variation we have and what the variables were going to be and all that stuff. All right, so we got our formula. Now we move on to the next part, which is, for any type of these variation problems, no matter what type of variation you have, once you have your formula set up, the next thing you need to do is figure out that constant of proportionality, k, right? And remember, there are always like two-step problems. First, you solve for k, and then you can plug the k in and plug in the other numbers they give you to actually solve the question that they're asking you, right? So to solve for k, we're going to have to use this next stuff here. A person who weighs 140 pounds, right? So the person's weight, W, is going to be 140, and is 70 inches tall, right? So the height, the H, is going to be 70, has the BMI equal to 20. So the capital B over here is going to be 20, right? So I can plug all those numbers in and then use that to solve for K. All right, so let me do that here. So my BMI, B, is equal to 20. So 20 equals K times the weight, W, which is 140 pounds, over H squared. H is the height, so that's going to be 70 squared. All right, and once again, since I use the letters W and H, I know where to put the weight and where to put the height. It's pretty easy to figure out if you label things conveniently like we did here. All right, and now I need to solve this for K, which means I need to do some work here. And a lot of these problems that involve variation are ones that I would recommend using a calculator for, because doing some of these computations by hand would be kind of ridiculous. A lot of these numbers get really big. So it's K times 140 over 70 squared. So the first thing I'm going to do is multiply that 70, well, you know what? Yeah, let me multiply that 70 squared to the other side of the equation. All right, so I'm trying to solve for K here. So since I'm dividing by this number, the opposite of dividing would be multiplying. So let me do 20 times 70 squared. All right, and when I say that, it looks like this, 20 times and then 70 squared, not like 20 times 70 in parentheses squared, right? You have to do the squaring the 70 and then multiply by the 20. So I get 98,000 equals K times 140, and then I divide both sides by 140. So when I do 98,000 divided by 140, I come out to 700. Right, so my K value, not really a good place to write it here. K is equal to 700. All right, so again, for these variation problems, no matter what type of variation it is, first thing you do is set up your formula. Again, reading that problem very carefully to make sure you have all the variables in the right place and you have the correct type of variation. And then it's plugging in all the numbers they give you in order to solve for that K value, right? That constant. Right, so we got all this now, so now I can erase all this stuff where they gave us all that information that we needed in order to solve for K. And now we're down to the actual question that we have to answer. Find the BMI of a person who weighs 165 pounds and is 71 inches tall. Well, when I get this K equal to 700 here, I put that back into my general formula. Right, my BMI is going to equal 700 times W over H squared. All right, so that K is 700. I put that into my general formula. Now this is the equation I'm going to use to actually answer my question. All right, the person weighs 165 pounds, so my W is going to be 165. Their height is 71 inches tall, so my H is going to be 71, which means my BMI is going to equal 700 times the weight, 165, over the height squared, so that's 71 squared. And now I just have to type that into the calculator and get my solution for this person's BMI. So it's 700 times 165 divided by 71 squared, and I get 22.9. And I think it said in the original problem, I did not write the entire problem up there. It was actually even longer than what I wrote up there. The BMI is always rounded to the nearest whole number. Right, so that's how they do the BMI. So if it's 22.9, the nearest whole number would be a BMI of 23. All right, so that would be the body mass index of a person who weighs 165 pounds and is 71 inches tall. All right, so there's our example of combined variation where we had, our BMI was directly proportional to weight, but it was inversely proportional to the square of the height, and so we had to put both of those things into one single equation, right? We had the multiplication up here and then the division here for the inverse variation. But once you get that equation set up, or you get that formula set up correctly, it's just a matter of plugging in all the numbers they give you, solving for K, putting the K in the formula, plugging in the other numbers they give you, and then solving for whatever it is you're trying to solve for, right? So the setup, for the method for solving all these problems is the same. The difference is, depending on the type of variation you have, what does this basic formula look like, right? That's what's different each time. Once you have that set up, though, you're doing the same steps, whether it's direct or inverse or joint or some combination of those variations. All right, so hopefully that all made sense as far as doing variations. All of these are word problems. Don't read through the problem and say, wow, that's a whole lot of stuff and a whole lot of numbers. I just basically give up because this is too hard, right? Identify the type of variation, set up the equation, put the numbers in. You can solve these types of problems if you just go one step at a time and work your way through it.